Glass production begins with raw mineral materials. Silica sand is delivered through automated conveyor systems. This material forms the structural base of glass. Raw materials move continuously toward processing. Conveyor speed remains constant. Material flow stays controlled. Storage systems regulate material supply. Batching preparation begins automatically. Consistency is established early. Recycled glass is introduced into the mix. Cullet volume is precisely calculated. Energy consumption is reduced. Batching systems measure exact proportions. Material ratios are digitally controlled. Uniform composition is achieved. Mixed materials exit the batching unit. The batch moves toward the furnace. Processing transitions smoothly. Raw material enters the furnace loading zone. Thermal exposure begins immediately. Physical transformation starts. Furnace temperatures rise steadily. Materials prepare for melting. Heat becomes the dominant force. The batch enters the high-temperature furnace. Temperatures exceed 1500 degrees Celsius. Solid materials begin to liquefy. Heat spreads evenly through the mixture. Particles lose solid structure. Viscosity begins to change. Impurities rise to the molten surface. Density differences become visible. Material purity is affected. Mechanical skimming systems remove impurities. Surface contaminants are separated. Clarity improves. Molten glass stabilizes inside the furnace. Chemical balance is restored. Uniformity is maintained. Molten glass flows toward forming channels. Flow speed is regulated. Preparation continues. Flow direction is mechanically controlled. Turbulence is minimized. Material stability increases. Temperature control preserves viscosity. Glass remains workable. Forming readiness is ensured. Molten glass enters the forming zone. Material division begins. Shaping preparation starts. Feeders guide molten streams. Flow volume remains consistent. Precision is enforced. Cutting mechanisms separate molten glass. Timing remains exact. Uniform portions are created. Glass gobs drop into molds. Positioning is synchronized. Shaping begins. Compressed air expands the molten glass. Internal pressure is controlled. Hollow forms emerge. Molds rotate during shaping. Surface definition improves. Geometry becomes fixed. Mold cycles repeat continuously. Opening and closing remain synchronized. Production rhythm is maintained. Formed glass exits the molds. Structure is complete. Products advance forward. Hot glass transfers onto conveyors. Handling remains automated. Direct contact is avoided. Products move toward annealing. Thermal regulation begins. Stress reduction is planned. Glass enters the annealing layer. Cooling occurs gradually. Internal stress is reduced. Temperature decreases in controlled stages. Sudden change is avoided. Structural integrity is preserved. Cooling continues along the layer. Molecular tension stabilizes. Durability increases. Glass exits the layer. Thermal balance is achieved. Products are stabilized. Inspection begins immediately. Visual systems scan geometry. Deviations are detected. Cameras analyze surface and shape. Measurements occur in real time. Accuracy is verified. Defective items are identified. Mechanical diverters activated. Faulty products are removed. Approved products remain on the main line. Flow continues uninterrupted. Efficiency is preserved. Surface clarity is inspected. Optical systems detect flaws. Transparency is verified. Wall thickness is measured. Laser sensors operate continuously. Uniform strength is confirmed. Final inspection confirms specifications. Process consistency is validated. Quality is ensured. Products align before packaging. Spacing remains precise. Movement is controlled. Packaging systems receive finished glass. Robotic arms position each item. Handling remains consistent. Trays are stacked automatically. Alignment remains uniform. Preparation for transport begins. Packaged glass moves toward palletizing. Stability is prioritized. Breakage risk is reduced. Robotic palletizers stack packages. Load patterns are calculated. Structural balance is maintained. Pallets move into storage zones. Logistics flow begins. Inventory is organized. Conveyor systems guide pallets. Routing remains automated. Human intervention is minimal. Shipments are prepared for dispatch. Pallets aligned by destination. Distribution planning is active. Outbound loading continues steadily. Movement remains predictable. Supply chains stay active. Rejected glass enters recycling systems. Material recovery begins. Waste is minimized. Glass waste is crushed into cullet. Particle size is controlled. Reusability increases. Recovered cullet returns to handling systems. Material loops close. Sustainability improves. Recycled material re-enters production. Cullet ratios are adjusted. Efficiency increases. Multiple machines operate simultaneously. System coordination is constant. Production scales efficiently. Forming machines run in parallel. Timing remains synchronized. Output remains stable. Production speed remains constant. Conveyor synchronization is maintained. Throughput stays predictable. Machine cycles repeat continuously. Timing prevents interruption. Flow remains stable. Sensors monitor vibration levels. Alignment deviations are detected. Mechanical stability is preserved. Maintenance systems track wear. Alerts trigger automatically. Unexpected downtime is avoided. Recycling lines operate alongside production. Processes run in parallel. Efficiency is maximized. Recovered material re-enters the cycle. Material efficiency improves. Waste is reduced. Environmental conditions are monitored. Airflow and temperature remain controlled. Operational balance is maintained. Energy consumption is balanced. Load distribution is optimized. System efficiency remains high. Production data updates continuously. Performance metrics remain visible. Process control is reinforced. Centralized systems coordinate operations. Automation replaces manual input. Consistency is maintained. Multiple lines operate simultaneously. System conflict is avoided. Output scales smooth. Shift changes occur without stopping. Control systems remain active. Manufacturing continues. Finished products exit the facility. Logistics schedules remain constant. Distribution flows outward. This process repeats thousands of times. System reliability enables repetition. Variation is minimized. Automation defines modern production. Manual adjustment is reduced. Consistency defines quality. Systems operate beyond individual oversight. Processes continue uninterrupted. This is industrial manufacturing.